talking about the concept of enthalpy in this lesson, right? Now, what is enthalpy? Well, enthalpy is really represented by H, and we can consider this really to be sort of the sum of all energy internal to the system, right? Its proper definition, which is usually the internal energy of a system, in other words, the system's heat, plus the product of pressure and volume, right? But for our purposes, we'll really just consider it as heat, right? And the change in heat, which is really the sum of the internal energies of the system, right? Okay, and the reason we're going to call it that is because when we observe a change in heat, which we will note to be delta H, this will be true. A system will change its heat, or it would really just be a change in heat if the energies are changed, if the pressure remains constant, which means there's no change in the volume, which means there's therefore only a change in internal energy. Okay, but for the purposes of the grade 12 examination, this is fairly simple. All you need to know is what delta H represents. It is the change in enthalpy, aka the change in heat, for your purposes in examinations, and it has a formula that it is the energy of the products minus the energy of the reactants, right? Energy of the products minus the energy of the reactants. And that's really what it's about. So if you have an endothermic reaction, delta H will be greater than 0 for an endothermic reaction, and delta H, or the change in heat, will be less than 0 for an exothermic reaction. Okay. And here we have an endothermic reaction. Okay, so what if I had to ask you a question and I give you a curve and I give you a graph, and the graph looks like that, and I tell you this part over here, which represents the energy of the products, that line is maybe 25 joules, right? And this line over here is 12 joules. Okay, and I give you another curve or another graph, and it looks like this. It starts high, ends low, starts with more energy, has less energy at the end, which means it releases more energy. And let's say this one starts at 30, and it ends up over there at, let's just say it's 21. Okay, if I have to ask you to calculate delta H, firstly, by the shape of this graph, you can tell me immediately this is an endothermic curve. Why? Because I started with little energy, I end up on the end with more energy. I started off with 12, I ended up with 25. Over here, I started off with 30, and I ended up with 21. So this one over here is endothermic. This one over here is what we would say as exothermic. Okay, and realistically, if I have to ask you to calculate delta H, you'll tell me in a physical science examination, delta H is equal to the energy of the products, because you get a mark for the formula, minus the energy of the reactants, right? And then you'll put in the values. Energy of the products is 25, minus is part of the formula, and then on this side we have 12. Okay, over here that then gives me an answer of 13, and that's 13 joules. And because delta H was positive, I can conclude that the reaction is endothermic. On the other side though, if I ask you to calculate delta H, you tell me delta H is equal to the energy of the products minus the energy of the reactants. And you can then tell me, well, the energy of the product starts off with 21, because this side on this side is the products, minus 30. And therefore I get an answer of negative 9. And because I've noticed now the value of delta H was negative, right? Specifically because of this, I can conclude that this reaction is exothermic. So there's a brief understanding of what delta H represents. In our systems, it would primarily be the change in heat. So if we ask you to tell us what delta H represents, you tell me it's the change in enthalpy or the change in heat. Okay? It is actually the change in heat, provided the pressure and the volume remain constant. Okay, delta H greater than 0 is endo, delta H less than 0, in other words it's negative, is exothermic. Thank you.